Alright guys, so we're back with the last video in the series for software. We already looked at Fritzing and iCircuit, but this time we're looking at Eagle and LTSpice together. We're going to do a very quick rundown. This is not going to be very detailed, but they're very important software. Okay, so we're actually ready here with the pinout for what we want to build. This is an LM1117 3.3 regulator, and we need basically the regulator and two caps. So let's go ahead and open Eagle up. And we want to open up a project. We could do just the schematic or the board, but we'll go ahead and we'll build a project so that it gives us a nice folder to put all of our files into. And once we've done that, we're going to call it regulator is fine. We can right click on that right there and go ahead and create a new schematic. So we're going to create a schematic and then we're going to move over to the board. Okay, so let's go ahead and open this window up and take a quick overview of how to get things started. So there's this icon on the bottom here that gives you your bottom left basically. And so there's a lot of tools here. You can see the properties, the layer tools. We're going to look at the move tool, the rotate tool, and whatnot. And you can go through all the tools in here. They're pretty straightforward. I'm not going to go into too much detail into all of those. We're actually going to just run through the quick project. So the most important one is the Add Components tool. So you click on this and it brings up this window and you pick your components. So let's go ahead and do that. And there's a lot of stuff in here, so you really need to know what you're looking for. So we're looking for a capacitor, and we'll hit enter and it'll give us a huge list of caps. And what we know is that they have to be 10 microfarads, and we also know that we need them to be polarized. So let's go ahead and here we go. Here's some 10 microfarad polarized capacitors. There we go. Boom. So once we select one of them, we can see the symbol and the what it looks like on a board on the top right, and that's what we want. So yep, let's go ahead and click OK. What's this? Oh, an error window. Great. Okay, I need to update my Eagle. Okay, so there it is, and it moves wherever the cursor is moved, and you can you can click on it, and every time you click, it sets one down. You can also rotate them, and you can change names and values and properties, and we'll see that a little bit more of that later on. So right now, we're just going to leave those two, and we're going to go back to our components tool, and we're going to look for the actual regulator. And there it is, and luckily there's only one. Great, so that's the one we're using. Let's go ahead and select it, hit OK. And great, error window again. This is great. Okay, so there is our regulator. And remember that it's in and out. You need to check the pin out because I messed up on this a while ago. I thought it was like the 7805, and it actually isn't. The order of the pins is not the same, and so I actually messed up. I had to start over again, and I was able to salvage the regulator though. And so here we go. If you right click on any component, you get a lot of the actions you can take with it, and you can also modify properties like the name. In this case, we're leaving cap as C2 and C1. We're not changing anything. So we need to connect it to VIN, and that reminds me, we need header pins to bring in voltage and take out voltage. So let's go ahead and type in pin and scroll down to pin head section, and we're going to use no, we'll use this one. Yeah, okay, so, and, oh, yeah, great, thanks. So there is our header pin for voltage in, and click on that, and click again for voltage out, and yeah, that's it. So let's go ahead and select the move tool. Let's order things around. And actually, before moving things around, let's just name these so we don't lose track. So we are going to right click on the, I don't know if it's because I didn't have the components tool. Let's go ahead and right click. There it is. Okay, so we go to the properties and we're going to name this VIN for voltage in, just so when we wire things we don't mess up. So there's voltage in and voltage out. Let's rename that. Okay, so that's pretty simple. We're done with that, and now we know where to wire what. So let's go ahead and move things around like I said and make space. So let's actually just separate these two and then just make some room here for the regulator. and bring this guy down here like that. Okay, and now to make connections, we're actually going to need something called the wire tool. And it's somewhere around here. There it is. Yeah, that's the one. Okay, and you just click on the component terminals or leads, and you click once, and it'll start wiring. And when you click once again, you can still keep wiring. To finish, you actually have to double click. So like right here, where my wiring connection ends, I double click, and as you can see, it turns from light green to dark green. And then start from here, the out, bring it into this cap, and start another connection from here to there. And it knows, I mean, if you connect two of them, it'll actually snap to that wire. So it knows that that's an actual connection. And okay, so now we have to connect the grounds from V in all the way to V out. And so this is a lot simpler. And you can click once anywhere on the canvas, and then that'll make a break or a bend. So right there, click once, there, click once again. And okay, I missed that. That's close enough. Okay, let me fix that. Should have a little bit higher. There. Okay. Okay, and then click once to start, click twice to finish, once, twice, and last one, once and twice. And we're done. All right, so that's pretty much it. That's our schematic. Let's go ahead and click save and give it a name. And that's going to go in our project folder, so it's already got that ready for us. We're just going to call it LM1117 regulator. Yeah, let's just leave it as reg. And okay, so click save, and this is our schematic file. All right, so what we want to do now is we want to use this button over here that says generate or switch to the board file. And since there is no board file to switch to, it asks us if we want to create it from the schematic. So yes, of course we do, and click yes, and it'll go ahead and create this board file for us with the name that we gave it. And let's go ahead and maximize this. All right, so as you can see, our components are right down there, and what we need to do is we need to bring these guys into this rectangle over here, which is going to be our board. Okay, so let's just drag these guys over. We got the move tool, so we basically place them wherever we want to, where we're going to want them to end up in the board or finalized board, and we can still move them around once they're connected, so that's not an issue. So let's we need a cap at the V out terminal and one near the V in terminal, and finally the LM117 or 1117. And we come down here. So there's a button down here. It's not the rat one. It's this one, the rat's nest. And it's not the outer router. So it's the rat nest. The rat's nest is going to basically use those air wires and turn them into or actually turn those connections that we made into air wires. So we want to go ahead and click on this rat's nest button, and you're going to see some changes over on the board, and there it is. So what we need to do now, as you can see, it moved the connections to the part of the component where they actually connect to, and we're going to have to rotate some of these guys and move them around so we can actually see the connections. The rotate tool is right here. Let's go ahead and rotate these. As you can see, the connections are clearing up a bit. You can see the actual connections, but we are missing the connections from the caps to the pins. Let's go ahead and rotate these guys just to make sure that they're in the final position, but we're going to have to go back to our schematic file, and something happened to our connections. So let's go ahead and click save just to make sure. Go back to our schematic file over here, and here we go. So we're going to have to delete those connections, but we obviously, or I obviously, messed up in making the actual connections. So there's a delete tool around here. Oh, here it is. Yeah, garbage can. Okay, so what we do is we basically click over whatever we want to delete, whether it's a connection, a wire, or a component. So let's go ahead and click over this and this one. And this one like so, and this one. Okay, so let's go ahead and make these connections again. So what happened was, you can see that the circles where the connection should be made have this little red line on the left side. If the wire doesn't come off of that red terminal, the connection won't actually be made to the component. So make sure you go from the left side, and there you go. And now they're all connected. We save, it updates the board. And when we go to the board, there, our wires are there. Okay, so once those air wires are in there, we rotate everything and align everything properly so that it you don't want to have air wires crossing each other, because those air wires are going to turn into traces pretty soon. So there's two ways of doing this. You can either auto route, or you can manual route, which is up here. And they both pretty much can give you as much control as you like, but the auto route is the fastest one. So I'm not going to make any changes at all. I'm just going to click OK, and there it goes. It's analyzing all the different ways it can go through, and there, it found it, and it laid down the traces of where those connections are going to be, and that's pretty much it. We're done. So we'll go ahead and click Save. And the last thing, if you want, you can export these files, so you can send them over to your PCB printer, or you can actually get a quote right here. It'll connect, and it'll get you a quote, and order them online and everything. And there's all the details of the traces, the thicknesses, etc. Okay, so that's pretty much it. That's all there is to Eagle. It's a pretty cool software, very powerful, and that's all there is to it. So let's go ahead and move over to LTSpice. So I hope you guys enjoyed this part, and don't forget to subscribe, and let's look at LTSpice. So here's an example. Here's a schematic file, and here's a board file of that schematic file. So this is what you end up with, whether you route it manually or automatically. Obviously, the automatic routing is an awesome feature, but this is what you end up with. So let me go ahead and zoom this out. And here we go. So there's a lot of detail. There's way more detail than you can do in Fritzing. Remember that Fritzing also had that PCB tab. Well, here you can define the thickness of the traces. You can define not just the top layer, but the bottom layer, and even middle layers in between if you want to route connections on the inside of the board. And it's incredibly detailed, and it has a lot of helpful features to help you manually route and make connections and leave spacing. It's a very, very, very powerful package. I really like Eagle for this, and I've created quite a few projects on here, and I've actually had the boards printed, and everything went great as long as I stick to the rules. Everything came out just fine. So that's what you get from schematic. You go to board, and that's, I believe, one of the most powerful things this software can do, and this is one of the main reasons people use it. So I got other projects here, and there's a lot of examples that come with the software itself. And in a later video, we'll get into exactly how to design a printed circuit board, and then have the design files created, and we can send those out, because that takes a lot more time and a lot more detail to do. But we'll definitely get into that in a future video. So I just wanted to run down that idea of what Eagle is mostly used for, and let me jump over to LTSpice. So this is the circuit that we're going to design. I'm going to go ahead and start anew here. So this is the window that you get, and as I mentioned, Eagle is more like Fritzing, and LTSpice, which is this one, is more like iCircuit in the sense that it'll let you analyze circuits operationally, like in the time domain. So what happens as time goes by. So we can go ahead and add components to create our circuit first, and then later on we'll go ahead and analyze the function in circuit. So we're adding some resistors here. You come over, you right click, and you can come and into draft and click on component. It'll bring you up a list, and you can look for voltage sources, resistors, capacitors, the usual stuff. And I've added in an op-amp one, and it's not in here. Here we go, components, and just type in op-amp, and that's not the, there we go. That's the one we want. And let's just place this over here. And once you select it, you can drag it around. And once you click, it'll set it down, and it'll give you automatically another one for you to place elsewhere. If you hit escape, it'll get rid of it. You can go look for a new component, or you can move or drag or whatever some other component. So to do it, you have to go to the move command, and then you got to come back and rotate it. In Mac, it's Control R, or Command R, sorry. So we're going to go ahead and finish this circuit. And as you can see, you can also add wires, which is what we're going to do now, to connect these components. So this is, in that sense, if you go to the node or terminal of a component and you click and drag, it'll actually drag the component instead of dragging a wire. I believe iCircuit would actually let you connect a component without having to select wire. I'm not sure, I don't remember, but okay, so I'm going to go ahead and finish this circuit. We're basically drawing the exact same circuit that we did in iCircuit when we did the op-amp. And to add grounds, you add a net and you label it ground, and it'll recognize it as ground, and there it is. If you want to duplicate a component or change its value, you right click on it, and it'll give you a menu as well. And that's actually how you change the values and labels of components. So you right click, and in this case it'll bring you the label for ground that you can type in. If you right click on something like a power source, it'll actually let you change the voltage on the power source as well as the name. So it's very basic, and it's quite intuitive. It's a little bit complicated on Mac, I think, because it doesn't have toolbars. But I've heard, or I think I've seen that on Windows it does, so that should be a lot easier for the Windows users. And okay, so we're almost done here. We need to start right-clicking on components so that we can change values. So here we're changing the value of a resistor. We're going to set it as 1K. I'm going to move this one. I'm going to set that to 9K. And we're going to start labeling nets or adding nets. And this is very useful because this will allow you to actually give a name to a node or a point on the circuit that you are interested in, so that when you do the transient analysis, you can actually just very easily click over that or select that node and have it graphed, which is very useful. So we're going to make sure to set the DC value for this. We're going to go in advanced because we don't want a, we do want a 1 volt. Wait, that's not what we want. We want a sine. Oh, here it is. Okay. We want it to be sine wave. We want it to be 1 volt. And we're going to give it, we need to define a frequency. Oh, okay, I know what's going on. Wait. The 0, okay, it's the offset. So if you notice, obviously, like I mentioned, I'm doing the exact same circuit I have at the bottom. So you notice it has the 0 here, and that what that 0 comes in from is because it's got an offset. So let me go write that in. We don't want any offset on ours, but we do want 1K frequency. Here we go. Okay, perfect. So 1 kilohertz. Okay, so our circuit is complete, and it's the exact same circuit I have at the bottom. And now we're going to talk about these commands up on the left side, the dot command. So those are spice directives, and the way that works is you have to write out the command for the analysis that you want to do, and let me go ahead and save this, and then you run with this button right here. So right now you hit the run button, and there's no analysis found because we haven't typed in anything. So the way to do this is you right click and you come over here to draft and you select spice directive. So in spice directive we go ahead and hit, we're going to write in .lib space opamp.sub, which is, no, not new line, sorry, let me erase that, go back, just okay. So that's one full command right there. That's something specific to the op-amp. Now here's the analysis, the .tran 5ms. 5ms stands for milliseconds, and the .tran stands for transient analysis. So go ahead and hit OK. And there we go, there are our commands. once our commands are ready, we click on the run button. It gives you a window. Let me go ahead and stretch this out down here so we can see what's going to happen. And this window is in the it's got 5 milliseconds of time domain, which is what we're going to be looking at, and that's what we defined. And there is the in node. So that's the voltage going in, and as expected, it's 1 volt, 1 volt amplitude. And the V out, when you click on that, it shrinks V in because it's way smaller, and then V out goes 10 from -10 to +10. So that's what you would expect from the op amp. Obviously, that's what it does. So there's your 10x gain right there. And you can keep adding nodes and stuff. Eventually, it might get a little bit crowded, and you might want to add a different window just so that you can keep some of these readings separate. Otherwise, things get bunched up. It's hard to read. But you can select a drop-down list to click on the nodes available. And the other thing is that it's pretty smart. So if you go and you select a node where the magnitude of the range is way smaller. So right now we're going from 10 to 10. So the 1 to 1 V in still fits in the 10 because it's a 1 unit step. But if you click and you select current, then here the amperage is way smaller. So it throws this x-axis over on the right side, and that goes in milliamps from -1 to 1 milliamps. So it's pretty smart. I mean, it tries to keep things nice and neat, and it does a pretty good job at it. So, all right, so that's pretty much the way you use this. It's a little bit probably less intuitive than iCircuit, but it's still pretty powerful. And there's a lot more analysis that you can do. I'm just covering probably the simplest one. And you can go ahead and keep adding more nodes and stuff. But we're going to look at probably more detailed examples in future videos. I just wanted to run over these videos with you guys so that you have a better idea of what these 4 tools are used for. And it's a good idea to keep them handy because they do come in handy at some point. So, all right, I hope you guys enjoyed this series and enjoy the videos.